for me.
Hello.
Oh, there we go. Now I'm live too.
Mine's online.
Okay, guys. So Seth is not here. He's on vacation, and Eric is as well. So the only one missing is Andrew, and he will be joining afterwards, I guess. So now, I'd like to present Dimitri, who is here as a guest, because we're going to discuss the lazy-val initialization SIP. So he's going to be the support for discussing that. And basically, right. So I think that you don't have any questions about the SIP process and how it works, right? Is it pretty clear by now? So I think that we can move on and start with Adriaan Moers and discussing the trait parameters. So Adriaan, you could just start presenting what the SIP is about and what do you think about it.
Can I just pause really quickly, because
sure.
Normally we on the on-air things we have an opportunity for people to ask questions, and there's like a screen, but I don't know if it's. I mean, maybe I should just join and be able to answer questions.
You mean the group chat here?
Yeah.
There's like a Q&A thingy at the
Yeah, the Q&A app is set up, so it looks like you can ask questions.
Okay, I'm going to do it from my laptop and turn off the camera and stuff, so just so you know. Okay?
And Sam is there, I think.
Hello.
Yeah. Hello.
Great.
Hello.
Just in time for trait parameters then.
Yes.
Okay. Yeah, I mean, I think I definitely like the SIP. I like that it unifies the way that classes and traits are defined. I think that's ultimately where we want to be. The restriction to make sure that initialization is predictable, let's say. I like that it's simple. I mean, people have argued that it's too restrictive, but I think it's better to err on the side of simplicity in this case. So I have no qualms with what is there. I do have a couple of questions to kind of complete the description, and that's mostly about interactions. So I think the easiest one, for example, is to say, well, now we can do context bounds on type parameters to traits. That was an implementation restriction before. So I think that's something that that should be mentioned in every SIP, is how it interacts with other features. I'd like a small discussion on what the different modifiers will mean, and if they they probably just mean all the same things as they do on classes. Like what's an override var x of type A in a trait, right? Things like that. What if you add the implicit modifier? That's something that we'll have to answer for context bounds. So I'm not saying these are crazy open questions, but I think it's good to have a centralized reference of all possible kind of tangential issues that arise when you introduce type parameters. Another example is maybe some guidelines around how this impacts your design. So when you add a trait parameter, that means that all the subclasses actually need to pass that parameter around. So that's another liability that you need to be aware of when you design your traits. And it's slightly different from adding a regular member to a trait. So that's another thing that I think would make sense to add to the description. And I don't know how we create that content, or whether we should actually address the technical issues here. Maybe Jorge, you can answer that.
Yes. Well, we should address the most important ones. Yes. Try to bring up some discussion about them.
Yeah, it all goes very fast, so it's good to have a record of these things, say sort of things to do or something. I don't know how we're gonna do that.
Well, Jorge is going to do afterwards from the video. So.
Yeah.
Okay. Good. Yeah.
Well, I can also send you my notes on this.
Another thing.
No, you don't.
Well, no. So another thing that, just to mention one more process thing, what I understood was that whoever got assigned to review a SIP would, try to summarize like maybe the to-dos. I mean, of course, we can like go through minutes and like try to do it as well. But I mean, in the spirit of actually kind of writing a review, we can discuss it maybe in detail here, and then if you could make some bullet points, if you got, I mean, like what, 3 sentences of things that maybe are required to bring the SIP to the next step, that would be really helpful to maybe do it in your own words. I mean, I talked to Eugene about it, but I thought it was just assumed by everybody. So if you could do that, I mean, really, it's like 3 sentences of just like, okay, this needs to be addressed, this needs to be addressed, and this needs to be addressed.
Since you're going to do it from the video, here are my notes. Just maybe freeze frame it there, and then we can take it from there later. Or I could digitize them in some other form.
That would be amazing. You could comment on the SIP in the issue tracker.
Mm-hmm. Great, I will do that. Yeah, so I think overall I like it. I think these are all pretty easy to answer questions, but I think we're going to get them several times, so I think it makes sense to record them. Mm-hmm. But otherwise, yeah, I like it. So thanks for assigning this one for review. It made it that was easy.
Okay. So how does it work? Should we make a decision now here, or?
So first, kind of implementation. So this is not in Dotty, right?
Oh no. I mean, sure. Yeah.
So we would need to present an implementation for Scala if we plan to.
No, I mean, like, we decide now that it gets numbered.
Yes, well, this is already numbered.
Right. So this is like officially like.
Yeah. So this is the first iteration of. Basically, we're starting now
with the formal evaluation. Has already a number. Okay, cool. Yeah. Got it. So we just want to have a status on this and next steps. Yeah.
Yeah. This is a rough review of all the design, and then ask so that in the next iterations we can. So review the implementation as well.
Okay, so that's a good question. So, we need an implementation for Scala C. So, how might we produce one for that?
Well, I think we might at some point. I don't know. I'm not ready yet to start talking about the roadmap for the next release while we're still sweating the current one. Yeah. But I see this as a great candidate for 2.13.
Okay, so that means we probably should give this then a fairly large horizon when, by the time we look at it again, it makes no sense to look at it next month because by next month we won't have an.
Right.
Mm-hmm. So
don't underestimate it.
Adriaan, you mentioned the feature interactions, right? Uh-huh. Like you mentioned context bounds. I would also throw out self types. And some of the weird expectations people might have with self-types.
Yeah, where's this in scope? Good point. Can I say like?
Right. Could we get that in the SIP? Like, is that can that be an action item that we start having discussion and interactions with other features?
Yeah, that's a great point. I'm adding it to my notes, and I'll propagate those to the tracker.
Thank you.
Okay. Also, I can't wait for it to make it. So 2.13, what? That's like in 6 months?
Roughly. Yeah.
Okay.
I mean, depending on how bleeding edge you want to be.
So 6 months, or
yeah.
Okay, so let's give it 6 months then.
Let's have a look at.
Okay, so then we should now move on to the other points of the agenda. Is the unsigned integer data types, and Martin Odersky is going to review it. Basically, in this SIP, which was before a slip, but it's really a SIP, we need to now do the formal presentation. So we need to give it a number if we like it, or if we don't, we just reject it.
Okay.
Close the view.
So what the SIP essentially? But maybe I should. To keeping to form, let me present. Go ahead.
Yeah.
So what I understood from Seb's document was that there are value classes, unsigned integers, unsigned longs, and I'm not sure whether there are smaller ones as well. Unsigned byte, unsigned byte form. Essentially these value classes, and there's an implementation for them. And the only way it affects the compiler right now is that Box's runtime with essentially the equality tests and the hash code should be adapted so that essentially we get the same guarantees for boxed versus unboxed values. I think that was sort of understanding that I had from that. So I'm a little bit on the fence on that one. So I think because I would much prefer it to be just a slip, just put it in the library and let people use it and see how they fare. And I feel that once we put it in the language, it's not going to end. There's going to be lots of interactions with other things. And the question we should ask ourselves, is it really the thing we want to spend our time on in the language? Because I think we're going to end up spending a lot of time if we start introducing constant literals, if we start to look at performance, all these things. So as long as it's a slip, I'm happy. So I would say it definitely meets the bar to get a number and go forward, but I would say I'm not sold on it yet. So that's sort of my ideally one question to Sébastien and Dennis is, can we initially just ignore the problems with Box's runtime and just put these things in classes and say, well, that's what valid classes are. They're not magical for equality. Would that be intolerable? Or could we just put it in like that and then see what people use it for and how popular they get?
Should I answer now? Or So the main problem with this Box's runtime thing, I mean, it's the cooperative equality, is that if we don't have cooperative equality in the semantics of those things, they're basically useless for the initial purpose, which is for interop with host languages. So native on one side, JavaScript on the other side. So if they stay as a library and they don't have the cooperative equality with the signed integers, well, we can't use them for the initial motivation of introducing them in the first place. So in a sense, they're useless. They're even worse than useless. They would be harming the situation in the case of at least of Scala.js situation. Because now we will have to support unsigned integers in addition that we cannot use for what we wanted to. And if we change the equality later, it's annoying.
So did I understand correctly that so if you have monomorphic types, so you know what the types are, then I assume the equals method of the valid class would take care of that. Oh, you need the ones on the integer side as well. Yeah. If you compare signed with unsigned.
Except if you can make the unsigned classes extend Scala number, because Box's runtime already knows about Scala number. Yeah. It will already choose the path to choose to go to the Scala number thing. Except that Scala number is a class.
Yeah.
So you cannot have a value class that extends Scala number.
Yeah.
And anyway, you cannot have a custom equals and hash codes on value classes. So if we want to make it completely library, and I would love to do that, we would need two other steps. We need to change Scala number so that it's an interface, and to allow changing equals and hash codes in value classes, which I think are two good things to have anyway.
Yeah. Docker allows equals and hash codes in value classes, so it solves that one. With the number, yeah, that's just Java lang number, but it's true that's
no, there's Scala number.
There's a Scala number?
Yes.
Yeah.
And that's the one. The Scala number inherits from Java long number.
Ah, okay.
But we could have Scala number be an interface.
Yeah, I agree.
That would work.
But as long as it inherits from Java long number, it's still still can't use it from a valid class.
Indeed. So it should also not inherit from Java long number.
But then you sort of have to retrofit big int and big decimal
think did we drop out? Or standard maps.
Oh, but no one talks about adding anything to us. Sorry.
The main account just lost internet, so hang on just a second. He's reconnecting.
The current implementation requires
Suddenly I just like run out of network split every time.
So far, I mean, we
Well, you know.
need to add more benchmarks and
I mean,
change.
somehow my laptop is still connected. I don't know.
Various ways we can implement it at that point. We can find a way that does not impact performance in all cases. At least all the cases where you don't actually go in the path where it's in unsigned integer. We would not harm existing use cases.
Just reconnect it. You need to reconnect it because there's no way to stop it unless you do.
Mm-hmm.
So Scala numbers used to unify between all the big Java numbers and the Scala numbers and like make all that so you can call them together, correct?
The Scala number is just Java number.
I'm sorry, I can't hear anything you're saying.
Yeah, I need it.
The feedback is getting a little out of control there.
I'm sorry, I didn't know how to use your laptop. So. Hello. Sorry, did it go away?
Maybe we can turn this into some kind of performance art piece where we.
Sorry, I'm not. I've got this muted, so that doesn't happen again. So I know you're talking to me, but you can hear me. I can't hear you. So say whatever you want about me right now.
Okay. I'm not celebrating. It's really possible.
Sorry, we're doing this one more time. Are you good?
Yeah.
I don't see you yet. All right. You did, yeah. There you go. All right, is everything fixed now?
Can you mute it? Doesn't work.
Oh, it's not muted. Sorry.
Okay.
We fixed.
Okay.
Is it good now?
Sorry, everybody. We're really sorry.
Good.
Okay.
Yeah, good. Okay.
So where were we?
Comments on unsigned integer data type.
But more specifically.
So more specifically, the Boxes runtime is very performance critical technique. So if you add one more case, standard maps get this going on because they use Boxes runtime to do comparisons for everything.
We're well aware of the performance critical aspect of Boxes runtime. We have several ideas, several things we do to benchmark, several ways we can think of runtime so that we won't impact the cases for the path. I'm quite confident that we can find something, but it definitely needs to. Definitely needs to find something before we accept this thing eventually. Anyway, that's for sure.
Any more feedback? Josh, Adriaan? Is Adriaan there? Oh yeah,
He is, but he's muted.
I am.
Okay.
Let's see if I can cause some feedback. Hello? Hello?
Good.
No, I'm just kidding. Yeah, no, I don't. I missed parts of the discussion, but I like the idea of making it a slip that depends on those two sensible SIPs. But I have to say that I missed some parts of the discussion there. So, but I think that's okay.
So maybe go now or something?
Well, Josh.
I was just gonna say I agree. Like I think it makes sense to try to keep as much of it library as possible and to limit any sort of compiler impact to a SIP. But the question then is the utility of Scala number. I think we want to figure out how important it is to actually keep that utility unless it's absolutely required for Box's runtime.
Well, if we want to make this the unsigned things library, then you need something like Scala number.
Right.
Right now, with the current state of the library, I mean, I guess someone could be using Scala number to implement complex numbers that have cooperative equality with doubles.
Well, I guess what I'm suggesting is you might be able to go with a type class approach to adapt onto things, because Scala number has a limitation in that it's not actually a Java. I mean, it is a Java number, and you can abstract over Java number, but you kind of have to pick your poison then, right? With this, so you could move to a type class approach if you're going to change it at all.
Well, you could not really have any type class-based approach in equality. In Scala equality is universal. There's no type class coming in.
That's true. That's true. Yeah.
Yeah. It would be good to somehow, at least when the types are known, that you know that we always then discuss the static code.
Sure, but that's really yeah. That's always.
So then the question is only if the types are not known.
Yeah, but that's what happens in maps.
Yeah. I mean, aren't we overthinking things here? Because no other language in the world is going to the troubles. They just all happily say, well, it's incompatible once you go generic. The equality is different. That's what C# says, that's what Java says, that's what they all say. So, and I think we already made a mistake going as far as we did. So do we want to go even further? Just say, well, if you want to have an unsigned key in a map, no, you won't hit it with a signed integer. It's different.
Well, C goes the opposite way. If you have a signed, which happens to have the same representation as an unsigned one, then they may be equal in some cases because you're just comparing the representations.
Yeah. Okay, so what I mean, that's probably food for thought.
Yeah.
Let's see the way to decide on this. So.
Okay, yeah. So what should we decide? Whether to give this a number and go ahead with it? That's the.
I think that's reasonable. Yeah. That we should vote on it or something.
Yeah. So I think the decision is deciding whether or not it gets a number, and then assuming yes, what the next steps are concretely, and it's your job to put that in the pull request to write it up as the reviewer. So.
That's it. So after giving it a number, we need a PR in the Scala website repo with all the information, because we're not going to use the Scala slip repository. We're going to update the Scala website as well. So we need a PR there, and as you have an implementation now, I mean, we don't need it. So in the next meeting, we will discuss both the design and implementation. And do you want to modify it or add more changes? You can, and we'll start discussing it in the next iteration then.
Okay, so then that means assuming it gets a number, Martin provides kind of like required next steps.
Yeah,
and then we schedule it to 1 month from now.
Yeah, 1 month from now.
That's another thing. It's like when the next iteration is that we discuss it.
Well,
it's not the
for
next
this
iteration.
particular one,
it's
it's useless because I'll be on vacation.
So then we schedule 2 months from now.
3 weeks out of the 4. So I think it's 2 months from now.
You tell us when you want us to look at.
So the next iteration would be in September. That we come back to this one.
It could be in September.
Yeah. I mean, August it's pointless.
Okay.
There won't be anything.
Yeah, but know that this is not the first iteration. This is like the formal presentation of the SIP.
Okay.
And the first iteration will start in September then.
Yeah.
Okay, cool.
Okay, so did the vote happen or what?
No.
No, we need to discuss on that. So, guys,
So
from left to right.
okay, so now we can just say
Okay,
very
so
quickly. So I propose that we give a number. Anybody seconds?
Sure.
Okay. So
I
Don't throw it in.
Okay.
It's kind
Any
of
notes?
awkward.
abstentions.
Attention from my side.
Okay, so we got it. Yeah.
So
Okay.
so verdict is we give this one a number, and in 2 months, Sébastien follows up on next steps that Martin provides.
and we need a PR in the Scala website.
Okay. Yes.
Okay.
Hmm?
So we move on and we go now with Eugene, who is going to present the SIP22 async. So go ahead.
Right. So SIP22 has a rich history. First of all, it has a mature implementation. So if you take a look at the GitHub repo, it has almost 500 commits and more than 50 issues, of which like one half is closed, which is pretty impressive. And so the two main contributors, Jason Zaug and Philip Haller, they're the authors of the SIP. And so the SIP has been around for a couple of years, and the implementation as well. And from what I can see, it's been warmly welcomed by the community. So it's around. It helps the use case. And now let's get into the details just a little bit more. So if you just open the SIP, there will be a very, very clear example of what it proposes. So essentially, there's a suggestion to add two methods with type signatures called async and await that simplify writing asynchronous code that works with futures. Essentially, I won't go into details about the implementation. I'll just mention that it uses macros to do a very involved code transformation. That creates that from asynchronous code creates a state machine, and that is capable of suspending its state and resuming its execution. So as shown by related work in other languages, it's kind of useful. So a lot of popular languages, they have adopted this. It all started with F# in computational expressions, and then it was popularized by C# with async await. And then like a lot of other languages like Dart, Python, Hack, they accepted something similar. And I should also say that in other languages, JavaScript and C++, the most major ones, there are proposals to accept async and await. So I have contacted authors while evaluating the SIP, and essentially they're pretty happy with the functionality, with a minor exception. So there's this restriction that await methods, they cannot be used in try-catch blocks. So as shown by C#, so there was a funny release note in C#6, I would believe, that said that, well, now await can be used in try-catch. We previously thought that it's impossible. It turns out it's not. So, well, I think this knowledge can be used to improve the library. And the authors, they have requested a timeout so that they have time to implement this feature, because it's apparently in high demand. And so additionally, what I would also recommend is well, documentation never hurts, and since we compare this feature with C#, which has a lot of docs and which is a very popular language, I think it would be good to satisfy the standard. And additionally, 2 years have passed since the SIP has been submitted, and so some new work it actually has been performed. For instance, in Dart, they not only have async await, they also have async star, which is like asynchronous generators, and they have await for, which can be used to consume these generators. So I'm not saying that this should be incorporated in this particular proposal, but I think a future work section, it would be very welcome, so that we understand whether it's possible to implement this functionality using existing features or what steps can be done in the future to accommodate that. So all in all, I think it's a very good idea to have async in our ecosystem. And since the authors have requested to postpone the to postpone the vote, essentially, I suggest that we do that. So according to our process, I think this means that we are closing the SIP. I will provide the feedback after our discussion, of course, and then when the guys are ready, we'll open it and continue the discussion. So what do you think, guys?
But it gets marked as dormant because the thing is not being touched. Even it has things it needs. It's planned not to touch it, and basically it gets out of dormant when somebody starts touching it and fixing what's supposed to be fixed. So you need.
That's right.
So just to reiterate, the next steps for this SIP, assuming, well, I don't think we need to vote on it, right? Because they suggested themselves that it should be dormant since they're not going to touch it right now. And then we reopen when they do start addressing the feedback that you're going to put into the ticket now.
That's right.
Then we reopen it and it gets reconsidered again once it's readdressed. Is that right?
Then in this case we will postpone it instead of like marking it as dormant, right? Because we postpone it under some conditions.
But we don't know when they're going to. The problem is that we don't know when they're going to pick it up.
Yeah, so when they pick it up, they just resubmit it. So that's the condition, that they pick it up, right? We postpone it for the moment being, and when they want to reopen it, they just do it, and we will process it.
What's the difference then between dormant and postponed?
So dormant is what happens when there have been 2 iterations, and there hasn't been progress on it, right? So there is no progress neither in the design or the implementation.
Yeah, but we can't apply those rules given that there hasn't been 2 iterations yet of this new process. So there's been many iterations on this async SIP, it's just nothing's happened. And we haven't had this current process in place. So we can't apply that rationale yet. After the second meeting, we can.
So what's the thing?
I mean,
the thing is that you mark it as dormant when there has been no progress in 2 months. While now we can choose and we can decide on the SIP, and we decide to postpone it under some conditions.
Yeah, but the problem is that it stays.
We can do that now. I mean, those are one of the 4 decisions we can make.
So it sounds like if it helps, it sounds like dormant means no one's working on it. Like nobody has touched it. It's literally dormant. Like nobody is going to touch it. Whereas this one, we think it's postponed in the sense that they're going to pick up and add try catch. Or do we think it's dormant in that until they actually pick up and implement try catch, we don't want to pay attention to it? I think that's the decision, right?
Well, I guess the point is that Jason wants to pick it up, assuming he gets time. I'm not sure it's like a guarantee, like a signature in, like on a contract that he's going to pick it up within 6 months or something. That's my ambiguity. That's the only reason why I'm why I'm confused, because I think postponed makes sense when, for example, like if Sébastien is going to go for to save the whales for the next year, and he doesn't plan on touching Scala.js in that period of time, he's going to say, okay, well, I'm going to postpone this until I come back from all of that stuff, because he's definitely coming back and he's definitely going to work on it. But I think dormant makes sense when like nobody's working on it, and we don't know for sure if somebody's going to pick it up again. That's
I agree with that rationale. It's so reasonable.
You can also
I support anyone saving whales. That's all I gotta say.
Yeah.
You could apply both rules, but if we do it like this, we will need to update the formalization.
I didn't hear you, Adriaan. What'd you say?
Oh, well, I actually had two thoughts. One is, can we use those statuses to maybe incentivize other people to, pick it up? Or, I mean, in this case, that's not really going to happen since there's already an implementation and so on. But, like, how about looking at it from that angle? Like, when you have a similar idea and you see that the SIP is postponed, will you think, well, it's postponed in terms of us wanting to accept it or the submitter wanting to complete the process? And so I think the higher level point behind that is when we impose deadlines, and that's kind of part of what the feedback that I gave on the document is, I think we should restrict our own deadlines, not other people's. Because you don't really know how busy they are or...
Yes, right. We are not restricting other people's deadline. Well, we are not restricting other people's time, right?
Well, when you say there hasn't been any activity for 2 months on their part, then it goes into a different state. That is a kind of deadline, right?
Yeah, because we need to schedule the next SIPs we're going to discuss for the next meetings. We need to have some status that really marks something as dormant or whatever. Right? Okay. Otherwise, we would schedule SIPs that there is no progress on it, right? And it doesn't make sense to discuss that.
Sure, I agree with that.
Between dormant and And postpone is that postpone the next meeting, you look at it. Torment, next meeting, you don't look at it, right?
No.
Or
with postpone, you don't look at it until the conditions that you set are met, right? So that could be someone needs to pick it up, or X library needs to be accepted before, or X zip needs to be accepted before, right? So those are conditions needed to, or necessary for the acceptance of a zip, or for at least resubmitting it, right? When they are met, you will bring it back to the process. If they are not, they're postponed, right?
Okay, I just in the interest of time, I say somebody makes a decision quickly and we move forward because
Yes.
this is a meta argument.
Yeah.
So I would postpone it.
All right, fine, postpone. So
Okay.
mark that as postponed, and then let's move on to the next one.
Okay.
So now it's Sébastien.
Yep.
He's going to review the improved lazy val initialization SIP. That's SIP 2020, right? Yeah.
So again, I'm presenting, but Dimitri, who's there, is the author. So maybe I'm going to say something wrong. You can correct me.
Formally, I'm not the author.
Oh yeah. Oh no. Yeah. Right. So this also is a long SIP that they expect from quite a while. So that the first reason it's introduced is that the current implementation scheme for lazy vals has several issues. One of the most important being potential deadlocks in initialization order when you would not expect deadlocks. So I mean, for details, look at the text. It's hard to explain in words. So there have been a few iterations, a few versions on the scheme. So there was one using. I mean, the basic idea of most of all these versions is instead of using one synchronized block and initializing the computing the initialization block within that single synchronized block is to have two synchronized blocks. One, first to detect whether it's initialized yet and whether I need to initialize it myself. Then release synchronized, execute the evaluation block, and then second synchronized block to broadcast the information that it's initialized. And then there are variations on how the synchronized block works, including using CAS instead of actual synchronized. So the most recent version of the document that is linked from the SIP mailing that Jorge has sent is not the latest development in that area. Some long discussion on Scala internals that was initiated by Dimitri with further refinements of those versions. And as far as I could tell, I mean, it's basically something that everyone sort of agrees that we need something better than what is currently in Scala C. The specifics of the best version, the best tweaks in terms of performance and deadlock avoidance are not completely clear which one is best, unless you have more insights than I did from reading all these discussions.
Well, the mailing list contains the benchmarks, and the most recent implementation actually, in the optimistic case, uses 0 synchronized blocks. And that's why it's faster.
Yeah, right.
So it only enters a synchronized block if it needs to.
Mm-hmm. So my general impression is that it definitely should be numbered. I mean, it's numbered anyway, but if we were to decide today, I would recommend that it is numbered since we're starting over. And it's something similar than with the trade parameters, right? We don't have a Scala C implementation right now, as far as I can tell. So we'll also need a Scala C implementation and maybe a definitive document, or putting in, I mean, rewrite an actual SIP document with the latest developments, not I mean, from the discussion on the mailing lists, and ideally including, I think that there are benchmarks, but that document should really include the benchmarks that show which particular variant is the best one.
Okay, so more documentation, more benchmarks, and another independent SIP, which will be submitted with a new number, right?
It might. I don't know.
Because this has a number, right? It's SIP 20.
Yes.
So we could reuse that one and just close it and resubmit it.
So I guess the question is whether someone would be up for updating the SIP immediately.
If by immediately you mean several months, then yes.
Several months, how many?
Let's say 2 or 3 months.
3 months.
I think
so
that's fine.
Okay, so then that means that the next iteration for this one is in 3 months, and we expect that to be done by then.
Mm-hmm. Okay. So now it's Eugene again. Presenting now the return of comma map trailing thing.
All right.
The trailing comma SIP.
Yeah, the trailing comma SIP, which was presented by Paul Phillips and was closed. Now we are.
Speak instruction.
Now it's been resubmitted as a new SIP. So I think that Eugene is gonna fill us in with all this.
This has been it's been resubmitted as a new SIP, and Eugene, go ahead.
All right, so let's hope this doesn't turn into bike shedding, and we'll stay concise and productive. So, well, long story short, since the issue indeed has a long story, if someone digs deep, I did that today. It was fun. Not gonna talk about that though, because we have a new story. So a couple of weeks ago, Dale Wynand provided an implementation of trailing commas for Scala C as a patch to Scala, with trailing commas being supported in just certain positions of the Scala grammar. Not everywhere, but in the key places, like argument lists, parameter lists, imports, if I recall correctly. So actually, on the issue, Dennis Shabalin, he provided an exhaustive list of places in the Scala grammar where we could support commas, trailing commas. So if someone's interested, please take a look. So anyway, what this proposal addresses, probably the most obvious thing is finally we'll be able to edit our SBT files, SBT build files, without any fear and annoyances. And then, speaking less about feelings and something more concrete, so this also makes diffs much better. So if you think about it, if you reorder some lines, if you add new lines at the end of an argument list, then with the current state of the art, Git shows two changed lines. Well, and with the new state of the art, you just consistently change one line. So these are all the the minor effects, but I'm just bringing them up here for comprehensiveness, so that we can estimate the effect of this on our community. So as I mentioned, there's already a prototype implementation. It turns out that it's pretty simple, just flipping a few bits in the parser. But yeah, as always, things are not as simple as they seem on the surface. So today, for instance, we had a discussion during lunch, and there was a very, very interesting corner case. So unfortunately, I don't have capability to project some code or a REPL here. So what happens if you take parentheses and then just say x, comma, inside those parentheses? So should we discard this comma and make this expression an equivalent of x because it's parenthesized, or should we make this expression mean construction of tuple 1? So that's an interesting question. So this is a very, very interesting edge case that we could take a look at. So surprisingly enough, well, if you take a look at related works, in Python they support trailing commas, then we will see that this expression constructs a tuple 1. And so in Scala we already have a tuple 1, and if you go to REPL and say tuple 1 of 42, you'll be really surprised. So just go there and take a look. We discovered that like half an hour ago. It was very, very interesting. So all in all, we can say that this proposal is kind of minor, but it handles the everyday annoyances, which kind of balances the bike shedding aspect, so to speak. And just to sum it up, we have an implementation, and Dale has also kindly volunteered to fix the tools. Scala reform, Scala parse, IntelliJ, Scala meta to support the updated grammar everywhere else. So, well, guys, let's discuss.
But we have this conflict that essentially, if we want at some point to find syntax for tuple 1, and I think if we want to become generic in tuples, we absolutely have to, then the trailing comma is the one that we currently have. It prints with a trailing comma, like you said, and it's a very good candidate for the syntax. So if we now say trailing commas are simply ignored, then essentially we shut the door for that in the future. So I think it's a minor convenience right now, but I would say if we shut the door in the future to having a convenient syntax for tuple 1, then I think no, we have to figure that out first.
I agree. Yeah, I just don't get the trailing comma thing, to be honest. I mean, I guess this is like a taste thing, but your IDE should just let you permute argument lists, and Git should learn how to ignore, punctuation in general. Like, it already does that for new lines, and spaces. I don't know. I'm personally not super in favor of this.
A particularly hacky idea, by the way, would be if we unify tuples and argument lists, and we have a way to have the apply methods of collections take in tuples of arbitrary size, then it doesn't matter anymore because you can send a tuple of 1 with a comma, right? There you go. Okay, it doesn't really solve the problem, but I thought it should be. Yeah. So if we're trying to unify tuples with things, I agree. I do think that this is a common enough annoyance, though, and having worked on a Pythonic build tool, it is kind of nice to have those commas. It irks me every time that you have to add the trailing comma in our style guide to the end of the list. Like, you have to have it there. It's mandatory. The linter will actually fail unless you have it there, which I don't like personally. But it does actually simplify diffs, especially for something which is heavily list-oriented, like configuration languages. So a build tool is a good example.
Mm-hmm. More feedback here, guys?
Well, for the tuple 1 case, if we're not completely decided on what we can do, it can just be an error for now. Right? We can still disallow the parentheses x comma parentheses, because now that doesn't compile, right? Unless if we can keep that specific case not compiling. So yeah, as an argument list, it should still be allowed because that's not and that's not a tuple, right? So.
I'm not sure whether we are not sort of removing any sort of consistency if we want to go forward in the end. I mean, another just to play devil's advocate here, another possible thing would be to say, well, if you want to make sure that the only possible interpretation is that it's an H list like tuple, then it's a trailing comma at the end. And then it's never an argument list or anything else. So that way we could essentially avoid the auto-tupling ambiguities or things like that. I'm just saying I don't know. But before having a design
much less regular than the way we have now.
Well, I don't know why. Well, it depends. I'm just saying we'd have to see the proposal for that first, and then we'd have to see, because I think that's the important proposal, how to do generics over tuples. essentially H lists in the language with the convenient syntax. That's an important proposal. And then we can see how trailing commas or not fit in. But I don't really want to sort of solve the easy problem first and thereby maybe make the hard problem over-constrained. That's my issue.
We're running into the end time of the meeting, guys. By the way, Josh had to drop out. I don't know how we want to organize the rest of the meeting.
Well, I think we need to make a decision about this and move forward. And then basically there's a list of slips which we should just look at and say. I mean, we don't have to spend as much time on the slips as in the SIPs, but we should have a look at them and see if any of them should be revived somehow. Mm-hmm. But I think what's most important is that we make a decision on this trailing commas thing, whether we want to give it a number and ask Dell to continue working out details, or or what.
Mm-hmm. So there are 4 more SIPs actually, which haven't been considered.
Or we maybe have them be presented in the next meeting. If they're not on the list, we don't look at them right now.
Yeah.
Okay. So any things about?
Well, this is like the first process, the first SIP that will go through under this process now. So we should decide whether we want to give it a number or not, and then we track its progress.
And this is the right time to ask the question: when do we give a number? what is the
we give it a number if we're in theory okay with the idea. Yes. It doesn't have to be that every single design issue has worked out yet. Mm-hmm. That's why we have a few iterations to go through those problems. But if in theory the idea sounds good and there's no major opposition to it, and issues can be resolved, like Dale said he would update the tools, make pull requests to them. I see this as issues being resolved. So, if everybody is okay in theory with this idea, like there's no major problems or issues with it, and it seems possible, then we, vote to give it a number if we're okay with it in theory. If, somebody's like remove types from Scala, of course, maybe we all disagree with that idea and then we don't give it a number, right? But if it seems okay in theory, we give it a number, which means we give it X iterations to come to fruition.
Yeah, that's right. That's right. Yeah.
So if you can put in the feedback that we have to clarify the interactions with tuple 1, then I guess we can give it a number and see what happens.
Mm-hmm.
Okay, so then we vote to give it a number. Who says yes? I would.
Okay.
Did you vote yes or no?
I voted. I abstained.
You abstained. So we have 3.
3 and.
Adriaan abstains or votes no?
I abstain.
Abstain. Okay.
2, 3 yeses, 2 nos.
Yeah.
2 abstentions.
Yeah.
What do we say with that?
It's 60%, but there was some 70%.
Someone get a calculator.
Yeah, well, I so the doc says 70%, but Josh dropped out, so it's impossible. Yes. Given the number of people, it's impossible to have 70%.
Yeah.
So do you want to what do you want to say?
So this is like because I wasn't expecting.
Okay, so make a decision.
Okay, now you have to.
So I guess that we could wait for Josh feedback on this.
Well, no, we have a meeting now, so we give it a number now or we don't.
In that case, I will give it a number. Yeah.
Okay. Okay, cool. So this is basically tentatively accepted for being sort of worked out further, especially in the tuple 1 case. Mm-hmm. And Eugene, you are going to write the feedback about what needs to be addressed in the issue, basically what concretely needs to be further worked out, and then we move forward in the next meeting, assuming that feedback has been addressed.
Yeah. So now we go through the slips in the queue. We're going to discuss like roughly about the JSON AST slip. I talked to the author, to Matthew, and he told me that, well, SBT Server 1 is using it, and it's also integrated with Play framework. So there has been no news from the last discussions in the slip repo. So basically, he was waiting for some feedback from Lightbends and EPFL. So I think that we could give him some feedback, and then, well, let him prepare for the next slip meeting, because this is a slip and it's going to be addressed by the new slip committee, right?
But the question is, if this goes forward, where would it end up? I would assume it would end up in the Scala platform, right?
Yeah, this is going to end up in the Scala platform.
So shouldn't we're probably not the committee who's mandated to judge what should be in the Scala platform.
No, we're not going to judge
So maybe we should just tell them, look, I think it would be good to start up the platform, and this looks like the ideal candidate for something like that. No?
Yeah, that's it. Yeah, we're only looking for feedback now.
Yeah.
We are not judging or deciding on this slip.
Yeah.
So, any more feedback on here? Do you like the idea, or do you think that it would be useful?
I agree that it would definitely be a prime candidate for consideration for the platform, and it's really, yeah.
Okay, Adriaan, something?
Yep. Same.
Okay, great. So now it's the extensions of features and promises, right? Promise. So the thing is, there is no implementation so far. So maybe we should ask the authors to provide one, or start providing one, or a proof of concept of something. And then we will iterate. Well, like, this has been discussed before, so this would go directly to the evaluation process, formal evaluation, and the slip committee will start reviewing both the design and implementation, right? So I guess that my feedback for the authors is that they should start working on the implementation. So if you guys have anything
Anybody
to add?
had a look at this so far? No?
Not in a while.
No.
It's been some time.
Victor Tang was very active in
He had a lot of
comments.
Yeah, comments about it. So I think basically I think the goal for iterating through these slips is to keep an eye on what exists, and like how we can ping these things for action again, and then basically next month we're going to have a separate slip meeting, so this should be out of the SIP committee by then, and there should be kind of a new process defined by Jorge in the next couple of weeks about how this should be handled. But I guess the point right now is to iterate through these things to see what we have in the first place, so there's some knowledge of the things that exist, and basically where they are. So I think this is less like we all make decisions, but like more we see what exists really quickly. So it's just running through the queue really quick to see what's there.
Okay, great. So next slip is the either monadic bias. Well, I think the monadic bias to either. So
it was merged yesterday.
Yeah.
Isn't that right, Adriaan?
Yep.
Okay.
All right, so that's actually resolved.
I guess that there is no point in discussing this.
Right? We can at some point like mark that as accepted and say that it went.
This is accepted.
All right, cool. So now we know.
Merge, so
not just accepted, but merged. Cool.
I like the synchronization we have, Adriaan. So now the next one is the Scala I/O targets.
I think
that's old.
That's very old.
I think the feeling was, rather than fuzzing around with this, we should start on a new I/O library like NIO.
Yes.
So we probably want to trust this.
There was a discussion about this.
Yeah.
I think this.
Far enough.
Wasn't there a presentation at Scala Days, better files or something like that? Or
something like that, yeah.
I heard some pretty good feedback about that one. I didn't see it myself, but People were excited about it.
Yeah.
That would also be. Is that a platform thing or a core library thing?
It's a platform thing.
Except if you paste the compiler on it, then it becomes a library.
Yeah.
Is the compiler depending on I/O right now?
It has no only Java.
No. Yeah, we use IO source for everything.
All compilers should have
Yeah. Yeah, I don't know. I wouldn't be so quick to make the decision. There, it might be more of a core thing than, or some small version of it could be more in the core than in the platform.
So
I don't know.
So it's a very big library. Compiler definitely doesn't need all of it.
Yeah.
At the very least.
Yeah.
Okay.
So we'll discuss this in the next SLIP meeting, which is going to be in August. Okay.
Okay.
And we'll tackle all the IO, well, the platform thing, right? And the platform design as well. So last but not least, it's the redesigning collections views. So George is not here, and he gave me some feedback on it.
Okay.
So basically, he told me that he thinks that the view replacement should have a twofold strategy. The new design.
So which
right?
what?
The
view replacement.
Yeah, the
Okay.
view replacement. We're replacing the views, right? In the Scala collections. So it should have like a twofold strategy. In the first place, he wants an iterator-based API which supports joins and efficient deferred operations with one-time parse. And on the other hand, he wants a transducer-based API which supports non-iterable collections and efficient deferred operations, but doesn't support co-iteration, and that is an efficient join.
Mm-hmm.
So he thinks that the design should have that.
We should probably talk to him. Yeah.
But as he is not here, I think that we are going to postpone this.
Okay. Yeah.
For
I would
the next
love to discuss with him further on that. Yeah.
Yeah.
Okay. Cool.
For the minor notice, I'm also the author of this.
Yeah.
Okay. Great. So do you have anything to add, Dimitri?
Well, I mean, I believe that the thing which we base on internally should remain the internal implementation, unlike in the current collection where it leaks everywhere. So we can decide on this, but then whether we want to do better reviews or not is a separate question from what were they based on.
Mm-hmm.
There are advantages and disadvantages in both approaches, and we have good examples of languages, which when the traducer, for example, based design, and that they have buffer bloat now.
Oh, so what's an example where an iterator wouldn't work, but a transducer would?
Well, I mean, well, first of all, depending on the corner cases, how would you implement them? Implement some operations like drop, you need additional support, and that's very easy to see in your collection strawman, even for standard one. So I believe that when we would say either transducers based or iterators based will already oversimplify.
Mm-hmm.
So it's actually all the implementations in either case will have qualities of both.
Okay.
But then they will also have some disadvantages of both.
It would be good to see transducers based designs and worked out as well. Yeah. I had the impression that iterators can do strictly more than transducers, but I'm happy to be proved wrong. So.
Well, I mean, if you make iterators into split iterators, then I would say that for practical use cases, you may be right.
Because transducers can't really do, what can't they do? Zip or, right, it's a stream fusion problem, zip or a partition. I think that's sort of the group by these sort of things.
Iterators are also bad in partition. I mean,
iterators can do zip, but not partition, and I think transducers can do neither. So.
I mean, that's a very similar situation with stream fusion and full dark builder fusion.
Mm-hmm.
I actually believe that that's the same issue.
Okay.
Okay. So I think that we should end the meeting right now.
Okay. Cool.
Well, thanks for attending, Adriaan, and the rest of the guys that were here before.
Okay.
See you guys.
See you next August. I will send.
Next August.
See you in August. Okay. I will send you all the details in a mail.
Great.
Thanks.
See you, Adriaan.
Bye, guys.
Have fun.
Bye. Good night.
Bye.
That's up.
Okay.
Hold on. I gotta do this.